Hey, 11.8. Last section of this chapter 11. Do you remember a while ago when we were talking about when really you were kind of first introduced to equations, such as y equals 2x or 5 equals 2x, and you got to figure out what x is. In that same chapter, we ended up talking about inequalities. Because inequalities, they're kind of just like equations, but there's not an equal sign, right? There's actually an inequality sign. So today, I'm going to show you how to graph an inequality. But let me show you what an inequality looks like. Y equals x minus 1. Is that an inequality? No. This is an equation. But what if we did this right here? Y is less than x minus 1. Yeah, that is an inequality. Because y is not equal to this side. It's less than that side. Or you could say less than or equal to, greater than or greater than or equal to, right? We're going to graph these inequalities the same way that we've been graphing, these linear equations, but then there's something a little different. So, I'll show you when we get there. Let's see what they do. Examples of linear equalities in two variables would be like this. Y is less than or equal to 2x plus 5. That's an example of a linear inequality. Or this, 2x plus 5y is less than 7. Now that's not in the y equals mx plus b format, but that's okay. It's still a linear inequality. Two variables raised to the first power. Okay, same here. Now, an ordered pair, like xy, 2, 3, or whatever, coordinate, is a solution of a linear equality if the inequality is true when the values of x and y are substituted into the inequality. What? Well, let's try something here. Here's our inequality. Let's just take this coordinate, 2, 3. Let's plug it in here and see if it would work out. 2 would be for x, 3 would be for y. 2 for x would make, well, this is going to be 3 less than or equal to 2 minus 1. 2 minus 1 is 1. So 3 is less than or equal to 1. Is 3 less than or equal to 1? No, it is not. So this is not a solution of that inequality, right? But you could find a lot of numbers that are. We just got to make x pretty big and y pretty small. So like if x was 10, and let's just choose this point, 10, 5. That would work, right? Because that would be 5 is less than or equal to 10 minus 1, which is 9. Is 5 less than or equal to 9? Yeah, it's less than 9. So this would be a solution. So, let's check this out. Example problem here. Checking solutions of a linear inequality. Tell whether the point is a solution of blah, 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 blah. This inequality. Well, first problem A here, they give you a point 0, 0. You need to plug the 0 in for x and the 0 in for y. Well, that would make this whole side 0, which is what they show you here, is less than or equal to negative 8. Is 0 less than negative 8? No, it's actually greater than negative 8. So 0, 0 is not a solution. Negative 1, 4, we can try those points, plug those in the right spot into this inequality, which is what they're doing here. And that comes out to negative 19 is less than or equal to negative 8, and that's true. So that is a solution. Okay, so you'll be doing some of that today, plugging in some coordinates and seeing if it's a solution or not. But we still haven't graphed a linear inequality. So let's check this out. Ooh, this is getting interesting. Notice how this graph has a line, which is what we've been doing, but then one side of this line is shaded. That's what we're going to be doing today. And some people have a tough time with understanding whether or not to shade above the line or below the line. I will show you how, okay? The graph of a linear inequality in two variables is a half plane, meaning that you are going to shade one side of this line, and the other side will be unshaded. A solid line indicates that points on the line are solutions of an inequality. So do you remember when, let's say you had x is less than 3. How do you graph x is less than 3? Remember on this, it's a number line. 0, 1, 2, 3, 4, 5. If x is less than 3, then that was an open circle on 3, because it doesn't include 3, and it goes to the left. X is everything less than 3. Or you could have whatever variable, right? Let's say you solved some equation for m or q or whatever. Q is less than 3. It would still look like this. Open circle. Less than or equal to 3 would have been a closed circle. Well, today, if you have less than or equal to 2x minus 3, okay, you have an inequality in two variables. This isn't just a point on a number line and then an arrow. This actually itself makes a line. So let's see, just pretend first off that this is an equal sign. Okay? So we're going to pretend that's an equal sign, and we should be able to graph that easily now. This is y equals mx plus b format. B is negative 3, so the y-intercept is negative 3. And then the slope is 2, up 2 over 1. 1, 2, 1, 1, 2, 1, 1, 2, 1. Okay, now we know where our line is going to be. But now, just like with this dot up here, making a closed dot means it includes 3, and an open dot means it doesn't include 3. This right here, we just graphed the line, right? So does y include the line, or is it just less than the line? Well, this is less than or equal to, so it includes the line. So yes, I can draw a solid line. If it was just y is less than 2x minus 3, then I would make this a dotted line because it doesn't include the line. So, where should I go from here? I'm going to blaze forward and just show you how to shade this, okay? So let's say you need to graph this inequality, which is what we just did, right up here. Solid line because it's less than or equal to. But now we have to figure out which half to shade. Now this is saying that y is less than or equal to this line. Y, remember, is the vertical aspect. So the upside or the downside, we'll say. This side over here would be on top. This side over here would be on bottom. Right? So if y, the vertical dimension here, y is less than the line, then we would be shading underneath the line, because the vertical part, y, is less than the line. That's the side we would shade. Now, we can check our answer. I'm going to cross this out for now. Because any point, this is what's cool about this, any point in this shaded region should work. It should be a solution of this inequality. So let's choose like a point way out here. Let's say this is 10, 0. That point, if I plug 10, 0 in for x and y, that should check, meaning that should be right. 10 would be for x, so 20 minus 3. What's 20 minus 3? 17. And then 0 in for y. Is 0 less than or equal to 17? Yes, 0 is less than 17. Well, that makes sense. That is a solution because it's in the shaded region. And any point on this line, this point right here, by the way, is 1, negative 1. This should work too. But notice what happens with this. Let's put 1 in for x, negative 1 in for y. 1 in for x, 2 times 1 is 2, minus 3 is negative 1. and then negative 1 in for y. So negative 1 is less than or equal to, we figured out the other side was negative 1. Is negative 1 less than or equal to negative 1? Yes, it is equal to negative 1, right? Negative 1 is equal to negative 1. So that is a solution. But imagine that this, our original equation, wasn't less than or equal to, it was just less than. Then our line should be dotted, which I'm just going to go like this to try to show you that, like, that's a dotted line now, right? And this point, 1, negative 1, is on the line. And if we plug it into this inequality, we would have gotten this. Negative 1 is less than negative 1. Is that a true statement? No. Negative 1 is not less than negative 1. This would not have been a solution, which is why we had a dotted line. Because a dotted line means any point on the line is not a solution of this inequality. Okay, that was kind of quick, but let's do another example and it'll become more and more clear. So, they give you 3 easy steps on how to graph a linear equality. First, change the inequality symbol to an equals. Graph the equation. Okay, then basically just change it to what we were doing last section. And then graph that line. Use a dashed line if it's less than or greater than. Use a solid line if it's got the equals. Okay. Number 2. Test a point in 1/2 of the planes to check whether it is a solution of the inequality. So don't shade anything yet. Just test like they did up here. They pretend they didn't shade this yet. Okay, they just graphed the line. They tried 3, 3 in the original inequality up here. And it didn't check. It didn't work. So they know that that's not a solution. So therefore, anything on this side is not a solution. They checked 0, 0. It's not a solution. They checked negative 1, 4. It is a solution. And they checked one that was on the line. It is a solution. So this side gets to be shaded, and it's a solid line. Let's look at an example. Graph this. Okay. Well, to graph that, first step was to change it into an equal sign. Y minus 2x equals 3. Now let's solve for y, which is what they do here. They add 2x to both sides, leaving you with y equals 2x plus 3. Okay, now that's not so tough, right? We can graph that. And so the y-intercept is 3, which is what they, let me put this up here, which is what they put right here. Y-intercept is 3. And 2 is the slope. So up 2 over 1. 1, 2, 1. Or down 2, back 1. Okay, now we know where our line is. Do we make it dashed or solid? Well, look back at your original problem, which is up here, and it was greater than, not greater than or equal to. So it doesn't include the line. So the line needs to be dashed. Okay. Now which side do we shade? Well, I gave you a shortcut trick, right? If this was y is greater than 2x plus 3, right, which is how that would have worked out had we kept our original greater than symbol. This means y, the vertical dimension, is greater than the line. So we should go up to the top side of the line. And this is what people have a hard time with. If I got a line right here, how do I know what's the top and bottom? Because it's slanted, right? Well, pretend that that line started at, or falls down to horizontal. Okay, if it was horizontal, you know the top is up here. And now it's just shifting up to there. So where's the top side? Over here. Okay? You'll be able to recognize that more and more. So the top side is this side, because it's got more space on top here. Bottom side is this side. So we shaded the top side because y was greater than the line. Alright, now, their method is just to check a couple points. So let's just check 0, 0. It's really easy to check 0, 0. Plug that into the inequality, into our inequality here. 0 greater than 2 times 0 plus 3. 2 times 0 is 0, plus 3 is just 3. Is 0 greater than 3? Nope. So that's not a solution. Okay, so I'm not going to shade this side. I'm going to shade the other side. One more example just to make sure you got it. Not going to read this whole word problem, but basically you've got this inequality, and then you're going to change that around to be in y equals mx plus b format, which they show you is this. Okay? You're going to graph this line, go up to positive 10 for the y-intercept. Slope is negative 3 over 2. So you need to assign that negative to the top or the bottom. Let's say it's negative 3 over positive 2. So down 3, 1, 2, 3, over 2, 2. 1, 2, 3, over 2. Okay? There's our line. Should this be solid or dashed? Well, our original had less than or equal to, so it should be solid. Okay? Do we shade the right side or the left side? Well, this became y is less than or equal to, y is less than or equal to this side, because we've got less than or equal to up here. So y is less than, so it's the bottom side. Okay? So we did this bottom side over here. And now we need to check your comprehension. Okay? So basically, so what does this mean? They're going to ask you, what does the graph mean at some point? And you got to be able not just to, so guys, we don't want you to learn this math stuff just so that you can draw a line on a piece of paper and then shade the correct side. No, there's actually meaning that goes with these problems. And so if you can understand this meaning, then you've got it. That's the whole point of this. So let's just take a look at this problem. See if you can understand this meaning. You're buying art supplies for your art club. You have 40 bucks to spend. Tubes of paint cost $6 each. Brushes cost $4 each. The inequality 6x plus 4y has to be less than or equal to 40. This makes sense, right? Because you can buy a certain amount of tubes. They cost $6 each. And you can buy a certain amount of brushes for $4 each. But whatever you buy has to be less than or equal to $40 because you only have $40. Okay, so you could buy a lot of tubes and very little brushes, or a lot of brushes and very little tubes. And students are coming back, so I'm going to hurry. Okay, how many tubes of paint and how many brushes can you buy? Well, any point in this shaded region could tell you, so let's say like 1, 5, okay? Is 1, 5, the point 1, 5, a solution of this inequality? Yes, because it's in the shaded region. Could you buy, 1 is the x dimension, and x stood for the tubes. Could you buy 1 tube and 5 brushes? Probably. That would be 6 plus 4 times 5 is 20. 26. Is 26 less than $40? Yes. You could buy 1 tube and 5 brushes. You wouldn't have spent all your money, but you don't have to, right? You just have to spend less than 40. So that's what that means, and I hope you enjoy.